somewhere in the middle of the Pacific Ocean, a wall of warm water the size of a continent has begun to slide east, and the switch that steers the weather for half the planet has quietly flipped. Forecasters now say the most likely outcome by this winter is a super El Niño, among the strongest ever measured, arriving on top of the hottest 11 years in human history. The last time the Pacific ran this hot back in the 1800s, tens of millions starved before anyone understood why. Today we have satellites to watch it coming, and almost no room left to absorb the blow. If the warnings the sky keeps sending land as heavily on you as they land on me, take a second to like this video and subscribe, drop a comment and tell me where in the world you're watching from. Now, let's get into it. For most of the last 3 years, the middle of the Pacific Ocean was running cool. The water off the coast of South America sat colder than normal, the trade winds blew hard and steady from east to west, and the whole system settled into the quiet, chilly pattern we call La Niña. Then, sometime this spring, the ocean changed its mind. The cool water faded, the winds began to slacken, and a shift that will reach nearly every country on Earth began without a single person feeling it happen. Here is what makes this strange. The most powerful change in the planet's weather begins as something almost gentle. A warm patch of sea spreading slowly across water so vast it could swallow every continent with room to spare. The Pacific is the largest single feature on our world. It stretches nearly halfway around the globe, and when its surface warms by even a couple of degrees, the atmosphere above it has no choice but to follow. By June, the scientists watching the equator had seen enough. The warm water was no longer a patch. It had grown into a band running thousands of miles along the equator, and its temperature had climbed past the line forecasters used to sound the alarm. They reached for the name this thing has carried for centuries, first spoken by fishermen off the coast of Peru because the warm water tended to arrive near Christmas. El Niño, the little boy. Then they did something that changes how the rest of this story reads. They issued an advisory, a formal warning that El Niño had arrived and would keep growing. Picture the Pacific as an enormous bathtub thousands of miles wide. For years, the wind had blown across the surface, shoving all the warm water up against the far side, over near Asia and Australia. It piled up there, a mound of warm sea sitting higher than the water around it, held in place by nothing but the steady push of the wind. Then the wind eased. And like any tub of water when you stop tilting it, that warm pool began to slosh back the other way, sliding east across the ocean toward the Americas. That slosh is the whole event in a single motion. As the warm water spreads east, it drags the storms and the rising air along with it. The engine of the tropics, the place where the ocean breathes its heat into the sky, lifts up and moves. Once that engine moves, the winds that circle the entire planet get rerouted behind it. Rain that used to fall over Asia goes missing. Rain that almost never touched the dry eastern Pacific suddenly appears. The whole global pattern bends itself around this one warm patch of sea. The unsettling part is how quiet the beginning looks. The trigger has already been pulled, yet there is only warm water moving slowly and a handful of instruments blinking a warning most of the world will never see. No roar, no flash, no single moment you could aim a camera at. The consequences are still weeks and months down the road, gathering strength while the surface stays calm. To understand how a warm patch of ocean can starve a harvest on the far side of the planet, we first have to understand the machine it just switched off. That machine keeps half the world fed and dry, and it runs on a loop of wind and water that most people have never once heard named. Long before anyone spoke the words El Niño, a giant loop of air was already turning over the Pacific, and almost nobody knew it existed. Warm water near Asia heats the air above it. That warm air rises, the way steam lifts off a hot cup, climbing miles into the sky. As it rises, it cools and dumps its moisture as rain over Indonesia, the Philippines, and the rainforests of the West Pacific. Then, drained and dry, that same air drifts east across the ocean, high above the waves, until it sinks back down over the cool water near South America. That falling air is why the coast of Peru is one of the driest places on Earth. Air coming down from above cannot make rain. It presses down, warm and empty, holding the desert in place, so the whole loop connects two opposite worlds. Soaking wet on one side of the ocean, bone dry on the other, joined by a river of air running the full width of the Pacific. Scientists call this loop the Walker Circulation, after the man who first noticed its fingerprints 100 years ago. Think of it as a conveyor belt lying on its side, stretching thousands of miles. Air rises in the west, travels east up high, sinks in the east, and returns along the surface as wind, round and round, day after day, for as long as the ocean stays the way it has always been. This belt does far more than decide where it rains. It sets the rhythm for the monsoons that feed billions of people. It shapes where fish gather and where deserts spread. When the belt runs strong and steady, farmers in India know when to plant, fishermen off Peru know where to cast, and the great harvests of the world arrive more or less on schedule. The entire food map of the planet is quietly balanced on this one turning wheel of air. El Niño is what happens when the wheel breaks down. Remember that warm water sliding east from Chapter 1. As it moves, it carries the rising air and the rain along with it. The place where the air lifts off the sea no longer sits over Indonesia. It drifts out into the middle of the ocean, sometimes all the way to the empty waters near the international date line. And once the rising air moves, the whole conveyor belt warps around it. Now the rain falls over open ocean where no crops grow. The dry sinking air lands over Indonesia and Australia instead, where forests and farms are used to being wet. The belt does not stop. It bends, sags, and in a strong event it can even try to run backward. Every place that depended on the old pattern suddenly finds the weather it counted on has packed up and moved somewhere else. 100 years ago, the man who mapped this loop had no idea what powered it. He could see the pattern in old weather records, a strange seesaw where pressure rose in one part of the world whenever it fell in another, yet he could not explain the engine underneath. The answer was hiding in the wind itself, in a belt of air that circles the equator and normally blows in one unbroken direction. When that belt of wind falters, the whole machine tips over, and this year it has already begun to falter. Stand on a beach anywhere along the equator in a normal year, and the wind at your back is almost always blowing the same way, from the east toward the west. Sailors have known these winds for centuries and named them the trade winds, because ships once rode them across the oceans to trade. They are among the most reliable winds on the planet, and they are the true muscle behind everything the Pacific does. These winds do something remarkable. As they blow steadily across the ocean surface, they drag the warm top layer of the sea along with them, pushing it slowly west, hour after hour, year after year. That is why the warm water piles up near Asia in the first place. The wind is forever shoving it in that direction, like a hand sweeping crumbs across a table into one corner. As long as the hand keeps sweeping, the warm water stays piled where it belongs. There is a second gift the trade winds give us. When they push the surface water west, cold water from the deep ocean rises up along the coast of South America to take its place. This rising cold water, called upwelling, is loaded with nutrients from the dark depths. It turns the sea off Peru into one of the richest fishing grounds on Earth. Tiny plants bloom in the cold water, small fish eat the plants, bigger fish eat the small fish, and a huge slice of the world's catch comes from that one cold, wind-fed strip of ocean. Everything depends on the wind staying strong. So what happens when it quits? Every few years, for reasons scientists are still working to fully explain, the trade winds weaken. Sometimes they fade for weeks. In the strongest events, a patch of wind near Asia can flip completely and start blowing the wrong way, from west to east. Weather scientists call these sudden reversals westerly wind bursts, and they act like a starting gun. The moment the wind stops pushing the warm water west, that great pile of warm sea near Asia is free to slide back east, exactly the slosh from earlier in this story. Picture holding a long tray of water and tilting it so all the water gathers at one end. The tilt is the trade winds. As long as you hold the tilt, the water stays put. Let the tray fall level, and the water rushes back across to even itself out. A westerly wind burst is the moment the tray goes flat. Once it does, no force is left to hold the warm pool in place, and the whole ocean begins to rebalance itself across thousands of miles. The cruelest part is the feedback that follows. As the warm water spreads east, it warms the air above it, which weakens the trade winds even more, which lets even more warm water slide east. Each step makes the next step easier. The system feeds on itself, and a small nudge in spring can grow into a monster by winter. Scientists watched exactly this loop switch on over the past few months. The winds faltered. The warm water answered. The feedback took hold. Once forecasters saw that loop lock into place, they stopped asking whether an El Niño would form. They started asking a far more unsettling question. How strong would this one become, and would it cross the line into the rarest category of all? Not every El Niño is a giant. Some are small, gentle warmings that come and go with barely a ripple in the wider world. So how do scientists tell a mild event from a dangerous one? They watch one particular stretch of ocean, a rectangle straddling the equator in the central Pacific, and they take its temperature over and over, week after week. They compare that temperature to the long-run average for the same patch of sea. If the water there runs half a degree warmer than normal for several months in a row, an El Niño is officially born. Half a degree sounds like nothing. You would never feel it swimming. Yet spread across an ocean region larger than the entire United States, half a degree of extra warmth carries a staggering amount of energy, enough to reshape rainfall on the far side of the planet. The strength climbs from there in steps. A warming of about 1 degree above normal counts as moderate. Around 1.5 degrees, forecasters start using the word strong. And when the water pushes past 2 full degrees above average, they reach for the rarest label of all. A very strong El Niño. The kind so uncommon that people who study weather for a living use a nickname borrowed from comic books. A super El Niño. 2 degrees. Hold that number because it is the line this whole story turns on. Below it, an El Niño disrupts. Above it, an El Niño can rewrite the year for the entire planet. To picture why 2 degrees over such a vast area matters so much, think of the ocean as a giant radiator for the sky. A radiator only warmed a little heats the room slowly. Crank it up, and the whole room changes fast. The tropical Pacific is the radiator that warms the global atmosphere. Nudge its temperature up by 2 degrees across millions of square miles, and you're turning up the heat on the air that circles the entire Earth. The winds, the storms, the rain belts, all of them feel it and move. The scientists tracking this event watch more than the surface. They send floating robots drifting through the deep ocean, measuring temperature far below the waves. They read the height of the sea from satellites in space, because warm water swells and sits slightly higher. They watch the winds, the clouds, and the pressure. All of it feeds into a single running number for that key patch of Central Pacific, and all season long that number has been climbing. By early summer, the water in that rectangle had already pushed well past the half-degree birth line and kept rising. The floating robots showed warm water building not only at the surface but deep below it, a reserve waiting to rise. The satellites showed the sea swelling higher across the Central Pacific. Every instrument told the same story. This El Niño was growing, and it showed no sign of stopping at moderate. That left forecasters with a decision they do not make lightly. Based on everything the ocean was showing them, how strong did they expect this event to get by the time it peaked in winter? When they ran their answer through every model they had, the result was so lopsided it surprised even the people who study these events for a living. Forecasting the ocean is a humble business. The people who do it speak in odds, never certainties, because the Pacific has fooled them before. So when a forecast comes back strongly pointing one way, it carries real weight. And this year, the forecast came back pointing one way, with a force that made experienced scientists sit up. Here is how they build these outlooks. They do not trust a single model. They gather 24 of them, some built on the physics of moving air and water, others built on patterns from decades of past events, and they run them all forward in time. Then they see where the crowd of models lands. If most of them agree, confidence rises. If they scatter, confidence falls. Agreement among many independent models is the closest thing this field has to a loud, clear signal. This summer, the models did something they rarely do. They nearly all agreed. Every single one of them pointed to El Niño conditions lasting straight through the winter. Almost none left room for the warming to fade or reverse. And when the forecasters asked the harder question, how strong will it get at its peak? More than half the models pushed the number past that critical 2-degree line into super territory. Turn that into plain odds and the picture sharpens. Forecasters put the chance of at least a strong El Niño near 9 in 10. The chance of a very strong super event they placed above 6 in 10. To say that out loud is to say something startling. The single most likely outcome for this coming winter, more likely than anything else on the table, is one of the strongest El Niño events ever measured by modern instruments. That word most likely is doing heavy lifting. For most of the seesawing history of the Pacific, a super El Niño has been the rare exception, the once-in-a-generation event people remember for decades. To have the models call it the front-runner, the expected case rather than the wild card, marks how loaded the ocean has become. The system is not merely warming, it is warming with momentum, and the momentum keeps building on itself. Picture a snowball at the top of a long hill. In most years, the ocean gives it a small shove and it rolls a little way before stopping in the flat. This year, the shove was hard, the hill is steep, and every instrument shows the ball already picking up speed. Forecasters are no longer guessing whether it will roll. They are trying to measure how big it will be when it reaches the bottom. Peak strength is expected to arrive in the heart of winter, sometime between the last months of this year and the first months of the next. That timing matters enormously, and we will come back to why, because the calendar of an El Niño hides one of its most dangerous tricks. For now, hold on to the shape of the forecast. Overwhelming agreement, rising strength, a better than even chance of crossing into the rarest and most punishing category the Pacific can produce. A forecast this confident raises an obvious question. If the models can see it so clearly now, why did almost no one see it coming a few months earlier? The answer lies in a strange weakness built into the calendar itself, a blind spot that arrives every spring and nearly let this giant sneak up on us. There is a season when even the best forecasters in the world go partly blind, and it comes around every single year. Weather scientists have a name for it that sounds almost poetic: the spring predictability barrier. During the northern spring, the Pacific becomes strangely hard to read, and forecasts made in those months fail far more often than forecasts made at any other time. Understanding why takes a small mental picture. Through winter, an El Niño or a La Niña usually stands at full strength, loud and obvious, easy for the models to lock onto. But by spring, the old pattern is fading away, and a new pattern has yet to take firm shape. The ocean sits in a kind of in-between state, quiet and undecided, wobbling between paths. A forecaster looking at the Pacific in April is like a person trying to guess the ending of a story from a page where nothing has happened yet. In that undecided moment, tiny nudges can tip the whole system one way or the other. A single burst of wind, a passing storm, a small shift in the deep water, and the ocean can lean toward warming or cooling. Because these small triggers are nearly impossible to predict weeks ahead, the forecasts made across spring carry wide bands of doubt. The models throw up their hands and say, in effect, we cannot yet tell you which way this tips. That is exactly the fog this year's event was born inside. Only a few months ago, the outlooks were cautious and split. Some models leaned toward a quiet, neutral ocean. Some whispered about a possible warming. Very few shouted about a coming giant. A person reading those early forecasts would have seen a shrug, a maybe, a wait and see. The Super El Niño now bearing down on the planet was, back then, one uncertain branch among several. Then the fog lifted, and it lifted fast. As spring gave way to summer, the ocean stopped wobbling and committed. The warm water surged, the winds cooperated, the undecided story suddenly had a clear plot. And the same models that had shrugged in April swung around in near unison, because now there was something solid for them to see. The barrier had done its job of hiding the future, right up until the future arrived. Think of it like fog on a mountain road at dawn. While the fog sits thick, you can barely see past your own headlights, and any turn ahead is a guess. Then the sun climbs, the fog burns off in minutes, and the whole road appears at once, including the sharp curve you were racing toward without knowing it. The spring barrier is that fog. Summer is the sun that burned it away, revealing a curve far sharper than most people expected. This is why so much of the world feels caught off guard. The warning signs existed, yet they hid inside the one season when forecasts mean the least. By the time the signal turned unmistakable, the event was already underway and growing. Precious months of clear warning were swallowed by the fog. Now the fog is gone, the road is visible, and one feature of the landscape ahead deserves a closer look before anything else. That warm pool sliding east is far larger and far deeper than the calm surface suggests. To understand the danger, we have to see how much heat it is truly carrying hidden below the waves. The most dangerous part of this El Niño is the part hidden from view. When we picture warm ocean water, we imagine a thin, sun-heated skin on top of a cold, dark sea. Yet the warm pool driving this event is no thin skin. It is a vast, deep body of heated water, reaching far below the surface, and its true size stays invisible to anyone standing on a boat looking down. Start with something you can almost see. Warm water takes up slightly more room than cold water, so where the ocean is warm, the sea actually sits a little higher, swelling upward like bread rising in an oven. During a strong El Niño, the Central Pacific can bulge upward by several inches across an enormous area. From space, satellites read that swelling with astonishing precision, and this year they have been watching the sea rise across the middle of the ocean like a slow, spreading tide. A few inches of extra height sounds tiny. Across the width of the Pacific, it represents an almost unimaginable amount of stored heat, and the height is only the smallest hint of what lies beneath. Below that swollen surface, warm water reaches down hundreds of feet, far deeper than normal. The floating robots that drift through the deep ocean have been sending back the same message for months. The warmth is not sitting on top. It is stacked layer upon layer into the dark. Here is why that hidden depth matters so much. Surface warmth can vanish in a single storm or a spell of cool wind. Deep warmth cannot. It sits below the reach of the weather, a reservoir waiting patiently. As the event grows, that deep heat rises toward the surface and feeds the warming, refueling it again and again. A shallow warm patch might fade in weeks. A deep one can power an El Niño for the better part of a year. Picture the difference between a puddle and a lake heated by the sun. A puddle warms quickly and cools by nightfall, its heat gone the moment the sun sets. A deep lake holds its warmth long after dark, releasing it slowly, because there is simply so much of it. This El Niño is the deep lake. The warmth measured beneath the waves this summer means the event has fuel to burn for months, carrying it straight through to its winter peak. Scientists measure this hidden reserve with a number they call ocean heat content, and it captures the warmth all the way down rather than only at the top. This year, that measure across the key Pacific region has run high, higher than it does in an average warming, marking one more sign that this event has muscle behind it. The surface tells a dramatic story on its own. The depth tells a far bigger one. There is a strange beauty in how the ocean gives itself away. A swelling of a few inches, spread across water so wide it defies the eye, read from hundreds of miles up in space, revealing a mountain of heat no swimmer would ever notice. The calm blue surface hides a slow, enormous furnace, and every instrument we own confirms the furnace is full. All that stored heat has to go somewhere, and the way it moves, the mechanism that carries it eastward and lifts it toward the surface, is a wave you could never see from a ship, thousands of miles long, crossing the entire ocean beneath the waves, quietly setting the whole event in motion. Some of the most powerful waves on Earth are ones no surfer will ever ride, because they travel hidden inside the ocean itself. One of them is the true trigger of an El Niño, a wave so long and so slow that it takes months to cross the Pacific, and so deep that the surface above it barely stirs. Scientists call it a Kelvin wave, and following its journey is like watching the fuse burn on the whole event. To picture it, forget the waves that break on a beach. Those live only on the surface. This wave lives deep inside the sea, along the boundary where warm surface water meets the cold water below. That boundary is not flat. It rises and falls, and a Kelvin wave is a swell that travels along it, a bulge of warm water pushing eastward far beneath the waves. From a boat, you would see nothing at all. Below you, a warm wall thousands of miles long would be rolling past, carrying heat across the ocean. These waves get their start from the same westerly wind bursts that kicked off the whole event. When the wind near Asia reverses and blows east, it shoves the warm surface water east and sets this deep swell in motion. The wave then travels on its own, sliding along the equator toward South America, a trip that takes about 2 to 3 months. All the while it drags warm water eastward and presses the cold layer down deeper, keeping the cold from rising to the surface. That last part is the killer detail. Remember the upwelling from earlier, the cold water that normally rises off Peru and feeds the fish. A Kelvin wave shuts it off. As the wave arrives in the east, it pushes the cold water down and out of reach, so nothing cool rises to replace the warm water at the top. The surface stays warm, the warming spreads, and the El Niño strengthens. The wave does not merely carry heat, it slams the lid on the ocean's cooling system. Think of the ocean as having a layer of cold water below and warm above, like oil floating on water in a jar. Tilt the jar gently and a slow bulge rolls along the line between them, from one end to the other. That rolling bulge is the Kelvin wave. It never breaks the surface, yet it carries enormous energy from side to side. In the Pacific, that bulge is thousands of miles long and carries enough warmth to tip the balance of the entire event. Forecasters track these waves obsessively because a strong one is a promise of warming still to come. When they see a large Kelvin wave launch from the Western Pacific, they know that months down the line its heat will surface in the east and push the numbers higher. This year, the instruments caught wave after wave marching east, each one delivering another pulse of warmth, each one refueling the event just as the previous pulse began to fade. That relay of hidden waves explains something that puzzles many people about El Niño: why the event keeps building for months rather than peaking all at once. The heat arrives in waves, literally, one deep swell after another crossing the ocean on a delay of months, and that delay hints at a far stranger truth about this whole phenomenon. The warming you can measure today is not the danger. The danger is what that warming does to the rest of the planet months from now, long after the wave has passed. The worst of an El Niño almost always arrives late. The cruelest feature of an El Niño is its timing. The event you can measure in the ocean today is a promise the atmosphere will keep months later, often long after people have stopped paying attention. By the time the real damage lands across the wider world, the headlines have moved on, and that lag is exactly what makes this thing so dangerous. Here is the sequence. The ocean warms first. That warming peaks, as we have seen, in the heart of winter. But the ocean does not hand its heat to the global atmosphere instantly. It takes time, several months, for all that warmth spread across the tropical Pacific to work its way into the wider air and lift temperatures around the planet, so the ocean peaks in winter and the atmosphere responds afterward into the following year. That is why a simple rule holds across event after event. The El Niño forms in one year and the record heat arrives in the next. The ocean does the loading through the winter. The world feels the full weight the year after. A warming that begins this year is a promise cashed the following year, and the world tends to forget it made the promise at all. The same delay runs through the harvests. A drought that El Niño triggers during a growing season does not empty a store shelf that week. The crop fails in the field, the shortfall works its way through markets, and the price shock and the hunger arrive months later, sometimes a full season or more behind the weather that caused them. By the time a family feels the cost, the drought that set it off has long since ended. Picture pushing a heavy swing. You give it a shove, and for a moment nothing dramatic happens. The swing creeps forward, gathering speed, and only later does it reach the top of its arc, far from the moment your hand left it. The ocean warming is the shove. The peak of global impact is the top of the arc, and it comes well after the push. Anyone watching only the moment of the shove would badly misjudge how high the swing is about to climb. This delay plays a quiet trick on the human mind. When the ocean warming peaks in winter, the world sees a strong El Niño and braces for immediate disaster. Then the immediate disaster does not fully arrive and people relax, thinking the danger has passed. Precisely then, in that lull, the delayed effects begin to bite. The record heat, the failed harvests, the rising prices, all arriving on a schedule that feels disconnected from the event that caused them. For this particular El Niño, the arithmetic of the lag points somewhere specific and unsettling. The ocean is loading its heat now and will peak this winter, which means the true reckoning, the record temperatures and the strained food supplies, point squarely at next year. The event is happening now. The bill comes due later. Understanding that delay changes how you read every warning that follows in this story. The ocean is charging up like a battery through the coming months, storing energy it will discharge into the atmosphere on a delay. To grasp how much energy is waiting to be released, we have to look at what the ocean has quietly been doing for decades, absorbing a staggering amount of the planet's excess heat, and why an El Niño is the moment it starts giving that heat back. The ocean has been keeping a secret that makes this El Niño far more dangerous than any that came before it. For decades, as the planet has warmed, the sea has quietly absorbed the overwhelming share of that extra heat. More than 9/10 of the warming trapped by our changing atmosphere has gone into the ocean, not the air. The water has been swallowing the heat, hiding it, sparing us the worst of it, 1 year at a time. This is the reason the land has stayed livable while the planet's energy has climbed. The ocean is a colossal heat sponge. Water can soak up enormous amounts of warmth with only a small rise in its own temperature, far more than air ever could. So the sea has taken the blow for us, drawing heat down into its depths and holding it there, a silent buffer between us and the full force of a warming world. An El Niño is the moment that buffer works in reverse. During the cool phase, the La Niña years, the ocean pulls extra heat down and stores it, and global temperatures ease off a little. During an El Niño, the ocean does the opposite. It releases stored heat back to the atmosphere across the vast tropical Pacific. The sponge gets squeezed, and the warmth it hid comes flooding out into the air we breathe. That is why El Niño years reliably rank among the hottest ever recorded. The event does not create new heat from nothing. It uncovers heat the ocean had been hiding, lifting it out of the water and into the sky, where thermometers and people finally feel it. Every strong El Niño is, in a sense, a withdrawal from an account the ocean has been filling for years. Here is where this particular event turns frightening. The account has never been fuller. Decades of a warming planet have loaded the ocean with more stored heat than at any point in the age of measurement. So when this El Niño makes its withdrawal, it will be drawing from the largest reserve the sea has ever held. The same mechanism that has driven past record years is about to run on a fuller tank than ever before. Picture a battery that has been charging steadily for decades, its stored energy climbing year after year. Most of the time it sits quiet, holding its charge barely noticed. An El Niño is the moment that battery discharges, dumping its stored energy out all at once. A small battery gives a small jolt. This battery is the largest the planet has ever carried, and it is about to discharge into an atmosphere already warmer than any humans have lived through. The scale is hard to hold in the mind. The heat the ocean has absorbed in recent decades dwarfs everything human machines produce. When even a fraction of that stored warmth surfaces during a strong El Niño, it can nudge the temperature of the entire planet upward for a year or more. And this event is shaping up to be one of the strongest, releasing its heat over one of the widest and deepest warm pools ever measured. All of that stored energy is about to meet a planet that offers no cushion. Because the world this El Niño arrives in is already the hottest it has ever been in the span of human record keeping, and that changes everything about how hard the blow will land. Every El Niño in history struck a planet that could take the hit. This one arrives on a world already running a fever, and that single difference may matter more than the strength of the event itself. The past 11 years stand as the warmest ever recorded, one after another, an unbroken streak of record and near-record heat. The baseline the world starts from has never been higher. To see why this matters, imagine two people stepping into the same hot room. One walks in cool and rested. The other walks in already flushed and sweating, having spent the day in the sun. The room adds the same heat to both, yet the second person, starting from a higher temperature, crosses into real danger while the first only feels uncomfortable. The El Niño is the hot room. The planet is the second person, already flushed before the door even opens. A strong El Niño reliably adds a temporary boost to global temperature. In a cooler world, that boost pushed the planet to a warm year that felt notable but manageable. Now the same boost gets added on top of a baseline already near the edge of what our climate agreements were built to hold. The extra warmth stacks on warmth that is already there, and the total reaches heights no previous El Niño could touch. This stacking is the heart of why scientists are uneasy. The event's raw strength is only half the story, the other half is the ground it starts from. A moderate El Niño on a cool planet is one thing. A very strong El Niño on the hottest planet in the age of measurement is another thing entirely. And there is no earlier example to reassure us, because the world has never been this warm when a giant arrived. The danger shows up most sharply in the extremes. Average warmth is only a number. What harms people are the peaks, the days when heat climbs past what bodies, crops and cities can bear. A warmer baseline shifts every one of those peaks upward. A heat wave that once topped out at merely severe now tips into deadly. A drought that once stressed a harvest now destroys it. The El Niño does not need to work as hard because so much of the ground has already been given away. Think of it like water rising toward the top of a dam. For years, the level has crept upward. An El Niño is a sudden surge of extra water poured in. In the past, the dam had plenty of room, and the surge sloshed harmlessly below the rim. Now the water already sits near the top, and the same surge threatens to spill over. The margin that once protected us has quietly disappeared, used up by years of warming we mostly did not feel. That vanished margin is the true reason this event demands attention. The Pacific has produced giants before, and the world absorbed them. This time, the world has far less to give. The same shock lands on a system with almost no slack left, and the results could break past thresholds that earlier events never approached. One threshold in particular has come to stand for the whole struggle to keep the planet safe. A single line drawn into an agreement signed by nearly every nation on Earth meant to mark the edge of dangerous warming. This El Niño may be the event that pushes the world across it, if only for a while. There is one number the entire world has agreed to fear: 1.5 degrees. It appears in an agreement signed in Paris by nearly every country on the planet, and it marks the limit that leaders promised to try to hold. The edge past which the dangers of a warming world grow sharply harder to manage. This El Niño may be the event that carries the planet across that line for the first time in a sustained way. The number measures how much warmer the world has grown compared to the time before we began burning coal and oil at industrial scale. For most of human history, that gap sat near zero. Decade by decade, it has climbed. Today the world hovers unnervingly close to the 1.5 degree mark, close enough that a single strong push could tip it over, at least for a spell. An El Niño is exactly that kind of push. Remember the ocean releasing its stored heat, lifting global temperature for a year or more. In a world already resting near the line, that temporary boost can be enough to nudge the whole planet past 1.5 degrees, even if only for a season. The warming from the event rides on top of the warming already banked, and together they reach a height the world agreed to avoid. A brief crossing does not mean the Paris promise is broken forever. Scientists are careful about this. The line in the agreement refers to a lasting long-term average, not a single warm year driven partly by a natural swing. A temporary breach powered by an El Niño is a warning shot rather than the final failure. Still, warning shots matter. The first time the world touches that line, even briefly, it tells us how little room remains before the crossing becomes permanent. Picture a car's speedometer with a red line painted at a speed the maker warns you never to hold for long. Touching that red line for a moment while passing another car will not wreck the engine. But if you find yourself brushing the red line more and more often, the message is clear. You're running the machine near its limit, and the day you cannot drop back below it is coming closer. An El Niño touching 1.5 degrees is the needle brushing red for the first time. What makes this moment sting is how it arrives. The world did not cross the line through some single dramatic failure. It crept there, year by warming year, until a natural ocean swing that has happened for thousands of years suddenly carries enough extra weight to push us over. The El Niño itself is ancient and normal. The world it now acts upon is the thing that has changed, loaded so heavily that an old familiar event can shove it past a modern red line. Forecasters watching this event believe the odds of a temporary crossing are real and rising, precisely because the ocean is releasing so much heat onto so warm a baseline. If it happens, the crossing will most likely show up not this year but next, when the delayed warming reaches its peak. The line, drawn to hold back the future, may be crossed on a delay we set in motion months earlier. That delay points at a specific year now looming on the calendar, a year that, if the pattern of every past El Niño holds, is poised to become the hottest that human beings have ever lived through. Somewhere in the near future sits a year that may go down as the hottest in the history of our species, and the El Niño forming right now is what will crown it. The logic runs straight through everything we have seen. The ocean loads its heat and peaks in winter. The atmosphere answers on a delay of months, so the record heat lands the year after the event takes hold. This El Niño is building now. The record points to next year. We have watched this exact pattern before and recently. The last strong El Niño loaded its heat one year, and the following year shattered the global temperature record, becoming at the time the hottest ever measured. The event did the charging. The next year cashed it in. That same rhythm, event first and record after, has repeated across the modern age of measurement with striking reliability. Now, line up the pieces for the event underway. It is forecast to reach strong, or very strong, at its winter peak. It rides on the warmest baseline ever recorded. It draws from the fullest reserve of a stored ocean heat in the age of instruments. Each of those factors alone would push temperatures up. Stacked together and released on the usual delay, they point at a year of heat unlike anything in the record books. The danger is not the average number people will read in a headline. The danger hides in the extremes that number smooths over. A record hot year does not warm every place gently and evenly. It concentrates its violence into heat waves that arrive earlier, climb higher, and last longer than the ones before them. It deepens droughts in the places already drying and drowns the places already prone to flood. The record is an average. The suffering is in the peaks. Picture a rising tide against a seawall. Each year the average level creeps a little higher. Most days you would never notice, but a record year is a king tide layered on top of that creeping rise, and it is the king tide that tops the wall and floods the streets behind it. The steady warming built the higher water. The El Niño is the surge that sends it over. The homes behind the wall feel the flood, even though the slow rise did most of the quiet work. There is a hard truth folded into this timing. By the time the record year arrives and the heat waves and failed harvests make the danger undeniable, the event that caused them will already be fading. People will look for something to blame in the moment, and the true cause will be an ocean warming that peaked months earlier and has since begun to cool. The reckoning always runs a step behind the crime. Scientists cannot promise the exact size of the record ahead. The event could peak as merely strong rather than super, softening the blow. Yet the direction is not in serious doubt. A warming ocean, a warming world, and a delay that lands the heat in the following year all point the same way. The most likely outcome is a year that tests the upper edge of everything we have measured. To understand just how far these giant events can reach when they strike a fragile world, we have to travel back nearly a century and a half to the last time the Pacific ran this hot. What happened then remains one of the largest human catastrophes ever set in motion by a shift in the sea. To understand what a truly monstrous El Niño can do, look back to the 1870s, when the Pacific unleashed one of the most powerful warmings ever recorded, and the world had no idea what was happening to it. Scientists who study the history of these events place that one near the very top of the list, a giant so large that modern researchers still measure other events against it. When forecasters warn that this year could rival the biggest since the 1870s, that ancient catastrophe is the yardstick they mean. In that era, no one on Earth understood El Niño. There were no satellites reading the swelling sea, no floating robots in the deep, no models running on borrowed physics. There was only the weather itself, arriving without warning or explanation. Rains that had come faithfully for generations simply failed. Skies that should have opened stayed shut. And across vast stretches of the planet, the pattern of wet and dry that people had built their entire lives around came undone all at once. The reach of that event still stuns the scientists who study it. It did not strike one country or one continent. It bent the weather across much of the world at the same moment, drying out great swathes of Asia while disrupting rains far beyond. A single warming in the Pacific, spreading its influence through the same conveyor belt of air we met earlier in this story, reordered the climate of half the planet for months on end. The scale was almost beyond belief for a phenomenon that begins as nothing more than warm water sliding east. What makes that event a true yardstick is how completely it matched the ingredients we see gathering now. A very strong warming of the tropical Pacific, a collapse of the normal wind patterns, a shift of the rains far from where people depended on them. The same machinery, running at full and terrible strength. The difference is that the people of that century met it blind, with no forecast, no advisory, no chance to prepare for a force they could not even name. Picture a village that has farmed the same valley for 1,000 years, reading the seasons by memory passed down through generations. Then one year the seasons simply refuse to follow the memory. The rains that always came in a certain month never arrive. The people wait and plant and wait again, unable to understand why the sky has turned against them. That was the world in the grip of that giant El Niño, a familiar planet suddenly behaving like a stranger, with no explanation to be found anywhere. Modern scientists reconstruct that event from old records, tree rings, coral, and the careful diaries of the time. What they find is a warming so large and so widespread that it stands as a warning across the centuries. It shows the upper limit of what these events can do when they reach full strength. It is the reason the word super carries such weight, because the last true super events in the deep record left scars that lasted for generations. The warming itself, terrible as it was, is only half the story. The other half is what that failed rain did to the people who depended on it. The consequence of that 1870s giant was not measured in degrees or inches of missing rain. It was measured in human lives, on a scale so vast that it ranks among the greatest disasters ever recorded. The true cost of a monster El Niño is not written in temperatures. It is written in the empty fields and the people who starved beside them, and the giant of the 1870s remains one of the deadliest disasters in all of human history. Tens of millions of people died in the famines that followed the failed rains, a toll so enormous that it is difficult for the mind to hold. And for a long time, almost no one connected those deaths to a warming patch of ocean thousands of miles away. The chain from sea to starvation is brutally simple. The warming Pacific moved the rains, as we have seen. Where the rains vanished, the crops failed. Where the crops failed, there was nothing to eat. In an age before global shipping and emergency aid could move food quickly across the world, a failed harvest in a farming region meant hunger, and a failed harvest across many regions at once meant catastrophe on a scale that emptied whole villages. The suffering fell hardest on the places least able to bear it. Regions that grew their own food and depended entirely on the seasonal rains had no reserve to fall back on. When the rain did not come, there was no second source, no store to draw from, no distant supply to fill the gap. The people who lived closest to the land, who had survived for centuries by reading the sky, were the ones the changed sky destroyed first. What haunts scientists most is how invisible the true cause remained. The people dying in those years had no way to know that an ocean current on the far side of the world had turned against them. They saw only their own dry fields and empty skies. The connection between a warm Pacific and a starving village would not be understood for another 100 years. The disaster struck in the dark, its cause hidden even from the survivors who lived through it. Picture a single thread pulled loose on the far side of a vast tapestry. The pull is gentle, almost nothing, a small warming in a distant sea. Yet the thread runs all the way across the fabric, and on the near side, where people live, whole sections unravel at once. That is how an ocean warming becomes a famine. A small change in one place, carried through the hidden connections of the planet, tearing open the lives of people who never felt the first tug. The reason this old horror matters so much today is the ingredients it shares with the present. A very strong warming. Failed rains across farming regions. Populations that depend on those rains to eat. Every one of those pieces exists in the world right now, and some of them exist on a scale even larger than the 1870s, because there are far more people to feed, and many still live at the mercy of the seasons. The comfort, and it is real, is that the world is no longer blind. We have the forecast that century lacked. We have global trade that can move food across oceans. We have warning, months of it, of exactly what is coming. The old famine happened because no one saw the ocean turn. This time we can see it clearly, which means the deaths of that era were a warning rather than a fate we're doomed to repeat. Events of that magnitude are mercifully rare. In fact, across the whole span of careful record, only a tiny handful of El Niños have ever reached the monstrous strength now being forecast, and counting them reveals just how unusual this moment truly is. Across nearly 2 centuries of records, the Pacific has produced only a small handful of true super El Niños, which makes the current forecast all the more startling. Since the middle of the 1800s, scientists count roughly 6 events that crossed fully into the monster category, the very strong warmings that reshape the world. 6, in more than 150 years. These giants are among the rarest large-scale events our planet produces. Rarity is exactly what makes them dangerous. Because Super El Niños come along only once in a generation or two, the world forgets them between visits. The infrastructure, the farms, the water systems, and the cities built in the quiet decades are shaped by ordinary weather, the mild years that make up almost all of living memory. When a giant finally returns, it strikes a civilization that has largely forgotten such a thing is possible, built as if it never could be. Each of these rare events has left its mark on history. Some triggered the famines and droughts we have already traced. Others brought floods and storms to places that rarely see them, or heat that shattered every record standing at the time. What they share is scale. An ordinary El Niño disrupts a season. A Super El Niño disrupts a year across the whole planet, touching harvests, fisheries, storms, and temperatures all at once. A coordinated global upheaval driven by a single warm patch of sea. The forecast for this year is unsettling precisely against that history. To say a super event is the most likely outcome is to say the planet is poised to enter a club. It has only joined a handful of times since before the invention of the light bulb. Forecasters do not use that word lightly, because they know how rare and how consequential these events are. For the models to point at one with such confidence marks how far the ocean has already tipped. Picture a coastline that suffers a truly enormous flood only once every few generations. Between those floods, people build homes closer to the water, plant fields on the low ground, and forget the high mark the water once reached, because no living person has seen it. Then the rare flood returns, finds a coast crowded with everything built during the calm, and does far more damage than it would have to the emptier shore of the past. A Super El Niño is that rare flood, returning to a world that filled in the floodplain while it was away. There is a further twist that sets this event apart from the 6 that came before. Every earlier Super El Niño struck a cooler planet, a world with more room to absorb the shock. This one arrives on the warmest baseline in the age of measurement, as we have seen, so even if it matches its predecessors in raw strength, it may outdo them in impact because it lands on ground already stripped of its margin. A rare event, meeting an unprecedented world. Counting these giants brings the danger into focus. They are rare enough to be forgotten, powerful enough to reorder the planet, and this may be the first to strike a world already running its highest fever on record. History gives us 6 warnings. The forecast suggests we're about to write the 7th, to see how a single one of these giants reaches into the lives of ordinary people, follow its influence to one place above all others. A land where 1 billion lives rise and fall each year on a single season of rain, a rain that an El Niño has the power to steal. Nowhere on Earth do so many lives depend on a single season of rain as they do across the Indian subcontinent, and nowhere does an El Niño reach with a more frightening grip. Each year, a vast flow of moist air sweeps in from the ocean and drenches the land in a season called the monsoon. More than 1 billion people wait for it. Their crops, their water, their whole year turns on whether those rains arrive full and on time, and a strong El Niño has the power to weaken them. The connection traces straight back to the conveyor belt of air we met at the start of this story. In a normal year, the rising rain-making branch of that belt sits over the warm waters near Asia, helping to pull the monsoon inland. During an El Niño, that rising air drifts east into the central Pacific, following the warm water as it slides across the ocean. As the engine of rising air moves away, the pull that draws the monsoon over the land can weaken, and the rains that should soak the fields arrive thin, late, or not at all. A weakened monsoon does not announce itself with drama. It shows up as a rain that starts a little late, pauses a little longer, and delivers a little less than the farmers need. Yet across a land where hundreds of millions grow their food, by hand on small plots, those small shortfalls add up to a harvest that comes in light. In the worst events, whole regions face a growing season without enough water to bring the crops to ripeness. The stakes reach far beyond any single country. The subcontinent grows staple crops that feed not only its own enormous population, but help supply the wider world. Rice, wheat, sugar, and more all lean on the monsoon. When those rains falter, the shortfall ripples outward through markets, nudging prices upward on the far side of the planet. A thin monsoon in one land can raise the cost of a meal in a country that has never felt a drop of that missing rain. Picture a single water tap serving an entire city, turned by a handle far away that no one in the city can see. For most years, the distant handle stays open and the water flows. Then, in an El Niño year, a hand thousands of miles out in the Pacific begins to turn that handle down. The flow thins. The city, entirely dependent on the tap, has no say in the matter and often no warning. That distant hand is the warm ocean, and the tap is the monsoon a billion people cannot live without. History shows how heavily this can land. The great famines of the past, including the giant of the 1870s we traced earlier, struck this region with terrible force precisely because a failed monsoon met a population living at the edge. The land has grown far more resilient since, with better storage, faster trade, and forecasts that give farmers time to prepare. Yet the fundamental dependence remains. A billion lives still rise and fall with a single season of rain. This year's forecast places that season squarely in the path of a strengthening El Niño, and weather agencies across the region are already watching their monsoon outlooks with unusual care. India is only the first stop on a tour of the world's most vulnerable harvests. From here the danger spreads to a continent in the south of Africa, where the grain fails in a different way, but for the very same reason. Far from the monsoon lands of Asia, another region grows its food at the mercy of the same distant ocean, and here an El Niño writes its damage in a different crop. Across the southern reach of Africa, families grow maize, the tall grain that fills the plates of the region and stocks its markets. Like the monsoon, that grain leans entirely on a single rainy season, and like the monsoon, that season answers to the warm patch of Pacific water thousands of miles away. The mechanism arrives with a twist. When the Pacific warms and the great belt of air shifts, the change in circulation tends to leave the southern part of Africa hotter and drier during its growing months. The clouds thin, the soil bakes, the rain that should feed the maize as it stretches toward harvest comes up short, and the crop that a whole region counts on falls thin in the field. What makes this corner of the world so exposed is how little cushion it has. Many of the farms here are small, worked by families who eat what they grow and sell whatever is left. There are fewer great reserves to draw on, less machinery to pull water from deep underground, and less room in the budget to buy food from far away when the harvest fails. So a dry El Niño season does not merely dent the numbers, it reaches straight into kitchens. History has already shown the pattern plainly. In past strong El Niño years, this region has watched its cereal harvest shrink and its need for imported food swell, as fields that normally fed millions suddenly could not. The drought did not have to be total to do harm. A single hot, dry growing season was enough to turn a self-sufficient region into one scrambling to buy what it could no longer grow. Picture a household that grows nearly all its own food in a single garden, sized carefully to last the year. Now imagine one season where the rain simply does not come, and the garden yields half of what it should. There is no second garden, no pantry stocked for such a year. The family must find food elsewhere, from markets that are also short, at prices that are also rising, because every neighbour faces the same empty garden at the same time. That shared failure is what makes an El Niño drought so cruel here. The wider world feels this too, though more faintly. When a whole region must import food it once grew, it draws on global supplies, adding pressure to markets already strained by shortfalls elsewhere. The dry fields of southern Africa become one more tug on the same rope that the failed monsoon is pulling, and the rope is the world's shared food supply, stretched a little tighter with each region that falls short. The danger here does not stand alone. It compounds with everything else the same El Niño is doing across the planet at the same moment, and that is the true shape of the threat, many regions failing together, each for the same distant reason. From the dry grain of Africa, the warm ocean's reach extends to a place that catches fire rather than simply drying out, the largest rainforest on the planet. The greatest rainforest on Earth, a place defined by water and green, becomes something terrifying during a strong El Niño. It becomes flammable. The Amazon, a forest so vast and so wet that it practically makes its own weather, dries out under the influence of a warming Pacific until the trees themselves can burn. A place built on rain, turned into a place waiting for a spark. The path there follows the now familiar shift. When the Pacific warms and the belt of air reshuffles, the rains that feed the Amazon can weaken and the heat can climb. A forest that runs on near constant moisture begins to dry from the leaves down. The rivers drop. the soil hardens, and the immense living sponge of the rainforest, normally too damp to catch, loses the wetness that has always been its armor against fire. A dry Amazon is a dangerous thing, because fire behaves differently there than almost anywhere else. In a normal year, a flame in the rainforest struggles to spread, smothered by the constant damp. In an El Niño year, that same flame finds dry leaf litter, dry undergrowth, and dry standing trees, and it runs. Fires that people set to clear land, which usually stay small and contained, can leap into the drought-stricken forest and spread far beyond anyone's control. The scale of what can burn is hard to hold in the mind. This is the largest continuous forest on the planet, holding an immense share of the world's living wood and a staggering variety of life. When a strong El Niño dries it and the fires climb, the smoke can blanket cities, the flames can consume vast areas, and creatures found nowhere else on Earth lose the only home they have. A forest that took thousands of years to grow can be scarred in a single dry season. Picture a wet sponge sitting safely beside a candle. As long as the sponge stays soaked, you could hold the flame against it all day and nothing would happen. Now let that sponge dry out completely in the sun. The same candle, the same flame, and suddenly the sponge catches and burns to nothing. The Amazon is that sponge. For most of history, it has been too wet to burn. A strong El Niño is the sun that dries it, and the candles are already lit all around its edges. The harm reaches far past the trees. A burning rainforest pours its stored carbon into the sky, adding to the very warming that helped dry it out in the first place. A grim loop where the fire feeds the heat that feeds the fire. And the forest that normally pulls moisture up into the air and helps make rain across a continent falls quiet, so the drought it suffers can spread to the lands that depend on it downwind. The most severe fire seasons tend to arrive not at the very start of an El Niño, but as it matures and the dryness deepens, another example of the delay that runs through this whole story. The forest dries slowly, then burns late, often into the year after the event takes hold. From the burning forest, the warm ocean's reach extends to the fields and plantations of Southeast Asia, where a different drought threatens crops that reach directly onto your grocery shelf. Some of the food in your kitchen right now traces back to a corner of the world that a strong El Niño can parch, and most people eating it have no idea. Across Southeast Asia lie the great growing regions for rice and for palm oil, two crops woven quietly into meals all over the planet. Rice feeds billions directly. Palm oil hides inside a vast range of packaged foods and household goods, and both depend on rains that a warming Pacific can steal. The pattern here echoes what we have seen, with the dry, sinking air of an El Niño settling over the islands and peninsulas of the region. Places accustomed to heavy tropical rain find the skies stingy. The paddies that grow rice need standing water to thrive, and when the rain thins, the water is not there. The plantations that produce palm oil suffer through the heat and drought, and their yield falls. A region built on abundant rain is left waiting for water that does not come. What makes this matter to someone far away is how deeply these crops are stitched into the world's food supply. Rice is a staple for more people than any other grain, and much of what moves across borders in trade comes from this region. Palm oil is even more hidden, folded into an enormous range of products most shoppers never think about. When drought cuts the harvest of either, the shortfall does not stay local. It travels through global markets and shows up as higher prices on shelves continents away. The reach is what surprises people. A dry season on a cluster of tropical islands can nudge the cost of a bag of rice in a distant city, or raise the price of countless everyday goods that quietly contain palm oil. The shopper never sees the parched paddy or the wilting plantation. They see only a number on a price tag creeping upward, with no obvious cause, driven by an ocean they have never seen doing something they never learned to watch for. Picture a single spring high in the mountains that feeds a river running down to many towns below. The people in those towns draw their water from the river without ever thinking about the spring. Then one dry year the spring slows to a trickle, and every town downstream feels the shortage at once, though none of them can see the source. The rice paddies and palm plantations of Southeast Asia are that spring, and the river is the world's food supply, thinning for everyone downstream. This is where the many regional failures begin to reveal their true danger. The failed monsoon, the dry African grain, the burning Amazon, and now the parched fields of Southeast Asia are not separate stories. They are the same story, told in different crops, all driven by the same warm patch of ocean at the same time. Each shortfall alone might be absorbed. Together they press on the world's food supply from every side at once. That pressure does not stop in the tropics. It reaches into the great farming nations of the south, the countries that grow much of the grain the world trades, where a strong El Niño can turn a bumper harvest into a disappointment and move the price of dinner tables far away. 2 nations in South America help feed much of the planet, and a strong El Niño can reach straight into their harvests, changing what the whole world pays to eat. Brazil and Argentina have grown into giants of global farming, producing vast quantities of the grains and beans that move across borders every year. When their fields do well, the world eats more cheaply. When a warm Pacific disrupts them, the cost ripples outward to dinner tables everywhere. The effect splits across the 2 countries in a way that shows how tangled El Niño's reach can be. In parts of Brazil, a strong event can bring hotter, drier conditions that stress the corn and soybeans as they grow, thinning the harvest. In parts of Argentina and nearby lands, the same El Niño can swing the other way, bringing heavy rain and flooding that drowns fields and rots crops before they can be gathered. One event, 2 kinds of damage, both cutting into the same global supply. This is the strange dual nature of a strong El Niño. It does not simply dry the world out. It shoves the rain around, piling it where it is not wanted and stripping it from where it is needed. A single event can leave one farming region gasping in drought, while another, not far away, drowns under too much water. Both outcomes ruin harvests. Both push prices in the same direction, upward, even though the weather that caused them looks opposite. The importance of these nations to the wider world is easy to underestimate. Over recent decades, they have become major suppliers of the crops that feed livestock and people across many countries. So a bad season in their fields does not stay a local problem. It tightens the global supply of grain and beans, and because these crops feed the animals that become meat and the products that fill shelves, the cost climbs through the entire food chain, reaching far past the farm. Picture a handful of large wells that supply water to a great many distant houses through a shared network of pipes. Most of the houses have no idea where their water comes from. But if a few of those big wells run low, or flood and turn muddy, every house on the network feels it in the same moment. Brazil and Argentina are among those big wells for the world's food, and a strong El Niño is the drought or the flood that fouls them, felt in kitchens that have never heard the wells' names. Stack this on everything before it, and the shape of the threat grows clearer and heavier. The monsoon lands, Southern Africa, Southeast Asia, and now the breadbaskets of South America, all leaning the wrong way at once under the same ocean's influence. The world's food does not come from one place, but a strong El Niño can strain many of those places together, which is precisely what makes it so hard to absorb. The rain El Niño steals from these farming lands does not simply vanish. It falls somewhere else, often in torrents, on places unprepared for so much water at once. To see the flip side of the drought, we turn to a coast that braces not for dust but for flood, where the same event that dries half the world drowns the other half. The same El Niño that parches continents can drown a coastline half a world away, and few places brace for that flood like the western edge of North America. While the monsoon lands and the southern forests dry, California often prepares for the opposite problem, a winter of relentless storms and rising water. One ocean event delivering drought to some and deluge to others, all in the same season. The reason lies in how an El Niño bends the great rivers of wind high in the sky. During a strong event, the fast, high-altitude wind that steers storms across the northern Pacific tends to shift and aim itself at the southern part of the western United States. Storm after storm gets funneled toward California, each one carrying moisture wrung from the warm Pacific. A region often defined by dryness suddenly finds itself in the crosshairs of a winter-long parade of rain. The most dramatic deliveries come in the form of what scientists call rivers in the sky. These are long, narrow ribbons of intensely moist air streaming in from far out over the ocean, carrying staggering amounts of water toward land. When one of these aerial rivers slams into the mountains of the west coast, it can dump an astonishing volume of rain and snow in a matter of days, enough to swell real rivers past their banks and send water pouring into towns below. A strong El Niño raises the odds that these events arrive often and land hard. Layered on top of the storms come other coastal dangers, higher tides and surging seas that a warm, active ocean tends to push against the shore. In the worst events, the combination of relentless rain, swollen rivers, and elevated seas has driven serious flooding along the coast, threatening homes, roads, and the people who live near the water. Picture a fire hose aimed not at a fire, but at a single hillside, held there for weeks. A gentle sprinkler over the same ground would cause no trouble, soaking in as fast as it fell, but a hose blasting the same spot day after day overwhelms the soil, sends water sheeting downhill, and floods everything below. A parade of atmospheric rivers is that fire hose, and a strong El Niño is the hand that aims it at the western coast and holds it there through the winter. The cruel symmetry is the point. The rain that Southeast Asia and Southern Africa desperately needed, the water the monsoon failed to deliver, does not simply disappear from the planet. An El Niño relocates it. It gathers moisture from one part of the world and hurls it at another, leaving drought behind and flood ahead. The same event, viewed from two coasts, looks like two opposite disasters joined at the source. This reshuffling of water reaches yet another continent, one that suffers both extremes at once. Because the very same El Niño that floods a western coast can, on the far side of the world, drown one region of Africa while it dries another, revealing just how strangely and unevenly this single event spreads its damage across the globe. Africa reveals the split personality of a strong El Niño more starkly than anywhere else, because a single event can drown one part of the continent while it starves another. We have already seen the south turn hot and dry, its grain withering in the field. Yet, at the same moment, the eastern horn of the continent can face the opposite fate. Deluged by rains far heavier than normal, its ground drowning under too much water. One continent, one El Niño, two disasters pulling in opposite directions. The mechanism reaches East Africa through a partner in the sky. A strong El Niño often works together with a pattern in the nearby Indian Ocean, tilting the flow of moisture toward the eastern edge of Africa. When these forces line up, they can drive far heavier rains than the region is built to handle. Rivers overflow, fields flood, towns wash out, and the same warm Pacific that dried the southern grain sends the eastern lands more water than they can survive. Too much rain harms just as surely as too little. Floodwaters sweep away crops and drown livestock. They wash out the roads that carry food and aid. They ruin stored grain and contaminate the water people drink. A family can lose its harvest to drought in one season and to flood in another, because the same restless ocean pattern that steals rain from one region dumps it on the next, offering neither the steady weather that farming needs. The danger deepens because floods carry a hidden second wave. Standing water left behind after a deluge becomes a breeding ground for disease and a source of tainted drinking water. So the flood does not end when the water recedes. It leaves behind sickness and hunger that can outlast the storms by months, compounding the harm long after the rain has stopped in regions with the least ability to recover. Picture a house where one room is left bone dry with a broken pipe, while another room floods because a different pipe burst wide open. The family cannot simply move the water from the flooded room to the dry one. The plumbing does not work that way. They are stuck with a drought in one corner and a flood in the other, both rooms ruined, both problems demanding help at the same time. Africa under a strong El Niño is that house, its rooms failing in opposite ways at once. This is the truth that makes a super El Niño so hard to manage. It is not a single disaster that responders can name and rush toward. It is many disasters at once scattered across the globe, some too wet and some too dry, each demanding a different kind of help in a different place at the same moment. The world's capacity to respond gets pulled in every direction, thinned out across a dozen crises that all peak together. So far this story has followed the El Niño across the land, through failed harvests and floods, but its reach does not stop at the shoreline. Some of its most far-reaching damage happens beneath the surface of the sea itself, in the cold, life-giving water that a strong event switches off, starving a food web that feeds a large share of the world. Some of the most devastating effects of a strong El Niño happen out of sight, below the surface of the ocean, where the event quietly switches off the machinery that feeds the sea. Remember the cold, nutrient-rich water that normally rises along the coast of South America, the upwelling driven by the trade winds. That rising cold water is the foundation of one of the richest fishing grounds on the planet. A strong El Niño shuts it down. The chain of life in that region begins with the cold water itself. As it rises from the deep, it carries nutrients that have settled far below, the leftover material of the sea. Near the sunlit surface, those nutrients feed an explosion of tiny drifting plants, the base of the entire ocean food web. Small fish eat the plants. Larger fish eat the small fish. Seabirds and sea mammals feed on all of them. The whole towering structure of ocean life in that region rests on the steady rise of cold, nutrient-loaded water. An El Niño pulls the foundation out. As the warm water spreads east and the Kelvin waves push the cold layer down out of reach, the upwelling stops. The nutrients stay trapped in the deep. The tiny plants at the surface, starved of what they need, fade away. And with the base of the food web gone, everything built on top of it begins to falter. The warm water that arrives is not merely warmer, it is empty, stripped of the food that the cold water used to bring. The effect ripples upward through every level of life. The small fish that fed on the vanished plants have nothing to eat and either die or flee to cooler water elsewhere. The larger fish that hunted them lose their prey. The seabirds and sea mammals that depended on the fish go hungry, and in the worst events they starve or abandon their nesting grounds. A single change in the temperature of the water empties an entire living region from the bottom up. Picture a tall building where the ground floor supplies food to every floor above it through a single stairwell. As long as the ground floor is stocked, the whole building thrives. Now imagine the stairwell suddenly sealed off, cutting the ground floor's supply from reaching upward. The people on every floor above begin to go hungry, one level after another, all because the connection at the bottom was severed. Upwelling is that stairwell, and a strong El Niño is the thing that seals it shut. This is not a small or distant concern. The fishing grounds that a strong El Niño disrupts are among the most productive on Earth, supplying a large share of the fish that the world catches. When they collapse, the loss reaches markets and dinner plates far beyond the coast where it began, and the communities that make their living from the sea can see their entire livelihood vanish in a single warm season. At the very base of this collapsing web sits one small, humble fish, so numerous and so important that its disappearance can shake the entire ocean economy of the region and ripple across the world. To understand how a warm current becomes an empty net, we have to meet the tiny creature whose vanishing sets the whole collapse in motion. One of the most important fish in the world is also one of the smallest. A silvery creature no longer than your hand, and a strong El Niño can make it vanish. The anchovy, humble and unglamorous, swarms in enormous numbers in the cold waters off South America, feeding on the tiny plants that the upwelling brings to the surface. It is caught in greater quantity than almost any other fish on Earth, and when it disappears, the shock travels far beyond the sea. The anchovy sits at a crucial junction in the ocean's food web. Below it are the drifting plants, and the smallest creatures that graze on them. Above it is nearly everything else, the larger fish, the seabirds, the sea mammals, all of which depend on the vast schools of anchovies as a central source of food. The little fish is the link that connects the bottom of the web to the top. Pull that link and the chain breaks in both directions at once. A strong El Niño pulls the link hard. When the upwelling shuts off and the tiny plants fade, the anchovies lose their food. The great schools thin, scatter, or flee to whatever cool water they can find. In the strongest events, the population can crash, dropping so low that the fish nearly disappear from the region for a time. The most abundant catch in the sea can become a scattering of empty nets in the span of a single warm season. The human cost lands fast and hard. Entire fishing industries are built around the anchovy, employing many people and supplying not only food, but the meal used to feed farmed fish and livestock around the world. When the anchovy vanishes, boats sit idle, workers lose their income, and the ripple spreads into the price of other foods far away, because so much of the world's animal farming leans quietly on this one small fish. A creature most people have never thought about turns out to help hold up a large piece of the global food system. Picture a single small bolt at the centre of a great machine, so ordinary that no one ever notices it. The machine hums along for years, and the bolt does its quiet job of holding two crucial parts together. Then one day the bolt slips out and the whole machine grinds to a halt, because everything depended on that one small piece staying in place. The anchovy is that bolt in the machine of the ocean economy, and a strong El Niño is what shakes it loose. History shows how severe these crashes can be. In past strong events, the anchovy catch has collapsed dramatically, sending shocks through the fishing economy and the wider food market, and taking years to recover fully once the ocean cooled again. The little fish is resilient and its numbers do return, but the gap it leaves during a strong El Niño can be deep and painful for everyone who depends on it. The warm water does more than starve the fish. It reaches into other corners of the sea and delivers a different kind of death, this one written in colour. Where the fish flee, another form of ocean life cannot move at all, and it pays for the heat by turning ghostly white and slowly starving in place. Beneath the warm tropical seas lies one of the most colourful living structures on the planet, and a strong El Niño can drain that colour away until the reef stands white as bone. Coral reefs, built over centuries by tiny living creatures, shelter a stunning share of all the life in the ocean. Their survival depends on a delicate partnership, and rising water temperature can shatter it in a slow-motion catastrophe called bleaching. The secret of a coral reef lives inside the coral itself. Each coral is a tiny animal, and within its body live even tinier plants that give the coral both its brilliant colour and most of its food. The plants capture sunlight and share the energy with their coral host. The coral, in return, gives the plants a safe home. This partnership built the great reefs of the world, and it works only as long as the water stays within a comfortable range of temperature. Heat breaks the partnership. When the water grows too warm and stays that way, the tiny plants inside the coral turn harmful to their host, and the coral expels them to survive. With the plants gone, two things happen at once. The coral loses its colour, fading to a stark white, and it loses its main source of food. A bleached coral is not yet dead, but it is starving, stripped of the partner that kept it alive, and if the heat lasts too long, it will not recover. A strong El Niño is a heat wave for the sea. As the ocean releases its stored warmth and surface temperatures climb across wide stretches of the tropics, reefs in many regions can bleach at the same time in a global wave of whitening. The strongest past events have triggered some of the most severe and widespread bleaching ever recorded, turning vibrant reefs into pale, silent ruins across whole ocean basins in a single warm year. Picture a bustling apartment building where the residents grow their own food in gardens on every balcony, feeding themselves and one another. Now imagine a heat so severe that every garden withers and dies. The residents do not vanish immediately, but their food is gone, and they begin to starve in their own homes, the once lively building falling quiet floor by floor. A bleaching reef is that building, its colour and its food stripped away by heat, its residents slowly fading in place. The loss reaches far beyond the beauty of the reef. A vast number of ocean creatures depend on coral reefs for shelter, food, and breeding grounds. When the reefs bleach and die, those creatures lose their home, and the fishing communities that rely on reef life lose a crucial resource. A reef can take decades to recover from a severe bleaching, if it recovers at all, so the damage from a single strong El Niño can linger long after the water has cooled. The warm water leaves its mark on the land as well, in a way that threatens not crops or coral, but people directly. Because the same swings between wet and dry that an El Niño drives can open the door to disease, spreading sickness through the very shifts in weather that this event delivers to region after region. A strong El Niño can spread disease across the world, using the weather itself as its carriage. The same swings between flood and drought that ruin harvests also create the conditions in which certain illnesses thrive, and history shows that the great weather shifts of an El Niño year have gone hand in hand with outbreaks of sickness in vulnerable regions. The event does not only starve people, it can make them ill. The clearest link runs through water. Where an El Niño brings heavy rain and flooding, the standing water left behind becomes a breeding ground for the insects that carry disease and a source of contamination for the water people drink. Illnesses spread by mosquitoes can surge where the floods create new pools for them to breed. Illnesses spread through tainted water can spread where flooding overwhelms clean supplies. The flood recedes, but the sickness it seeded remains. drought carries its own dangers. When water grows scarce, people are forced to use whatever sources they can find, including unsafe ones, and the crowding around shrinking water supplies can help illness spread. Hunger from failed harvests weakens bodies, leaving them less able to fight off disease. So both faces of an El Niño, the flood and the drought, can open the door to sickness in their own way, striking populations already stressed by the loss of their food. The reach of this effect follows the reach of the weather. Because a strong El Niño reshapes rainfall across many regions at once, it can raise the risk of disease in many places at the same time, from the flooded lands of one continent to the drought-stricken corners of another. The same event that strains the world's food supply can strain its health at the same moment, spreading its burden across both fronts. Picture a still pond that stays clean as long as fresh water keeps flowing through it. Disturb the balance, either by flooding it with dirty water or by letting it shrink into a stagnant puddle, and the pond turns unhealthy, breeding the very things that make people sick. An El Niño disturbs the balance across countless ponds, rivers, and water supplies at once, tilting them towards sickness in region after region, all from the same distant shift in the sea. The regions most at risk are, once again, the ones with the least ability to protect themselves. Places with fewer resources to control insects, ensure clean water, and treat the sick feel the health effects of an El Niño most sharply, layered on top of the hunger the same event may bring. The disease and the food shortage compound each other, each making the other harder to bear, in the places least equipped to fight either. This spreading of harm across so many fronts at once, food and water and health and sea, is the true nature of a super El Niño. But its reach extends even to the storms themselves, reshaping where the great tempests of the world form and where they fall quiet, in a global reshuffling of the planet's most powerful weather. A strong El Niño does not simply add storms to the world or take them away. It moves them, calming the seas in one ocean while stirring them to fury in another. The event reaches into the birthplaces of the planet's great tropical storms and rearranges them, quieting some regions and unleashing others, all through the same shift in wind and water we have traced from the beginning. Consider the Atlantic first. During a strong El Niño, the changes rippling out from the warm Pacific tend to increase a force high in the atmosphere called wind shear over the Atlantic, a difference in wind speed between low and high altitudes. Tropical storms hate wind shear. It tears their tall, spinning structures apart before they can grow strong. So an El Niño tends to suppress the Atlantic storm season, making it quieter than normal, offering the coasts along that ocean a measure of relief. The Pacific tells the opposite story. The same conditions that calm the Atlantic tend to energize storm formation across parts of the Pacific. The warm water and shifted winds create a friendlier environment for tropical storms to form and strengthen there. So while one ocean grows quiet, another grows dangerous, and the total number of great storms does not so much fall as relocate, shifting from one basin to another under the influence of the warm equatorial water. This trade-off carries real consequences for the people living around each ocean. A quieter Atlantic season may spare some coastlines, yet the coasts and islands of the affected Pacific regions can face a more active and threatening season in the same year. The relief in one place is paid for by heightened danger in another. The El Niño does not make the world safer from storms. It redraws the map of where the danger falls. Picture a room with several fireplaces and a single hand that controls how much air feeds each one. Turn the airflow away from one fireplace and its flames die down to embers. But that same air has to go somewhere, so it rushes into another fireplace and sends its flames roaring higher. The total fire in the room has not vanished, it has moved. A strong El Niño is that hand on the airflow, quieting the storms of one ocean by feeding those of another. The reshuffling reminds us that an El Niño is a global rearrangement rather than a simple, one-directional disaster. It gives with one hand while it takes with the other, calming here and enraging there, drying one land while drowning the next. This is why its full effect is so hard to sum up in a single sentence. It touches nearly everything, and it pushes different parts of the world in different directions at the same time. The storms are only one part of a larger reshaping of the world's weather. The deepest reach of a strong El Niño runs through the great rivers of wind that circle the planet high above, the currents that steer winter itself across entire nations. To understand how a warm patch of tropical ocean can reach all the way to a snowstorm over a distant city, we have to follow those high winds and see how the event bends them. The reach of a strong El Niño extends all the way to the winter weather of nations far from the tropics, because it bends the great rivers of wind that steer the storms across the globe. High above the surface flows a fast current of air called the jet stream, a ribbon of wind that circles the planet and guides where storms travel and where cold and warmth settle. A strong El Niño can shift that ribbon, and in shifting it, reshape the winter for whole continents. The connection begins, as always, with the warm water and the rising air above it. When the engine of rising air moves out into the central Pacific during an El Niño, it sends ripples through the atmosphere that travel far beyond the tropics. These ripples nudge the jet stream, altering its path across the wider world. A change that starts over the equatorial ocean reaches up and out until it is steering weather thousands of miles away, over lands that never feel the tropical warmth directly. Across the United States, this shift follows a recognizable pattern during a strong event. The jet stream tends to dip southward over the southern part of the country, dragging the storm track with it. That brings wetter, stormier weather to the southern states, the same mechanism that funnels rain toward California. Meanwhile, the shifted winds can leave the northern tier drier and milder than usual. The winter map of the whole country gets redrawn by a warm patch of ocean far to the south and west. The effect is a tendency rather than a certainty, and this matters. A strong El Niño does not guarantee any single storm or snowfall in any single place. It tilts the odds, making certain patterns more likely across a whole season, while the day-to-day weather still depends on countless smaller forces. So forecasters speak of raised chances and shifted patterns, not promises. The El Niño loads the dice for the winter without controlling every roll. Picture a long garden hose lying across the ground, spraying water as it goes. If you nudge the far end of the hose even slightly, the stream of water sweeps across the yard, soaking a whole new stretch of ground that was dry a moment before. The jet stream is that hose high in the sky. A strong El Niño is the nudge at the tropical end, and the sweep of the water is the winter storm track, shifting to drench regions that expected a dry season and spare ones that expected rain. This long reach is what makes an El Niño a truly global event rather than a tropical curiosity. It begins with warm water on the equator and ends with a rearranged winter over distant continents, connecting a patch of ocean most people will never see to the snow that falls or fails to fall on their own streets. The whole planet's weather is more connected than it looks, and a strong El Niño reveals just how tightly. Every thread we have followed so far, the failed harvests, the floods, the fires, the collapsing seas, and now the bent winds of winter, comes together into a single danger. And when they combine, layered on top of a world already warmer than ever, they create something more threatening than any one of them alone, a stacking of shocks with no room left to absorb them. The true danger of this El Niño is not any single effect, but the way all of its effects stack on top of one another and on top of a world already pushed to its limit. Take everything we have traced: the failed monsoon, the dry African grain, the burning Amazon, the parched Asian fields, the disrupted South American harvests, the collapsing fisheries, the bleaching reefs, the spreading disease, the shifted storms, and imagine them arriving not one at a time but together in the same window of months. That is a super El Niño. Each effect alone might be manageable. The world has faced a single failed harvest before and absorbed it by drawing on supplies from elsewhere. It has weathered a bad fishing season, a regional flood, a difficult storm year by leaning on the parts of the system that stayed healthy. The strategy for surviving any one shock is to borrow strength from everywhere the shock did not reach. But a super El Niño strikes everywhere at once, leaving fewer healthy places to borrow from. This is what makes the stacking so dangerous. When many regions fail together, the usual cushions vanish. A country whose harvest fails cannot easily buy grain from abroad if the exporting nations are also struggling. A region short on fish cannot easily make up the protein if farming everywhere is strained at the same time. The connections that normally let the world share the burden of a local disaster instead spread the strain, tightening the whole system at every point at once. Now layer on the warmest baseline in the age of measurement, the fever the planet was already running before this event began. Every one of the El Niño's effects lands harder because the world had so little margin to start. The droughts run drier because the heat is already high. The heat waves climb higher because the baseline was already elevated. The shocks do not merely add together, they multiply, each one made worse by a world already stretched thin. Picture a bridge designed to carry a certain weight, with a comfortable margin built in for safety. For years, heavier and heavier loads have crossed it, using up that margin bit by bit, until the bridge sits near its limit even on an ordinary day. Now send a single massive load across, all at once. On the bridge of the past, with its full margin, the load would have crossed safely. On the bridge of today, with its margin already spent, the same load pushes it toward the breaking point. The world's food and water systems are that bridge, and a super El Niño is the massive load. This stacking of shocks on a marginless world is the heart of why scientists watch this event with such unease. It is the reason a warming of a couple of degrees in a distant patch of ocean can threaten so much. The event itself is old and natural. The world it acts upon has changed, loaded and stretched, until an ancient force can push it past thresholds it once cleared with ease. There is one more feature of this danger that makes it especially hard to face, and it has nothing to do with the size of the shocks. It has to do with their speed. Because a super El Niño delivers its stacked blows faster than the slow machinery of farms, cities and governments can adapt, creating a mismatch between the pace of the threat and the pace of any response. Some disasters are survivable simply because they arrive slowly, giving people time to adapt, and the deepest danger of a super El Niño is that it does not. It delivers its stacked shocks on a timescale of a single season or two, far faster than the slow machinery of human society can shift to meet them. The mismatch between the speed of the threat and the speed of any response is a danger all its own. Consider how slowly the systems that feed and shelter us actually change. Farms cannot be moved to wetter ground in a season. New crops suited to a drier climate take years to develop and spread. Water systems, storage, and the infrastructure that moves food across the world are built over decades. These systems are strong precisely because they are steady, designed for the ordinary swings of weather, and their strength is also their weakness. They cannot turn quickly when the ordinary swings suddenly become extraordinary. A super El Niño exploits exactly that slowness. It arrives over months, peaks over a single winter, and delivers its worst effects across the following year, then fades. The whole event, from formation to aftermath, plays out faster than a farm can be relocated, or a water system rebuilt, or a new resilient crop planted across a region. By the time society could adapt to the shock has already done its damage and moved on. This is why forewarning matters so much, and why it is not enough on its own. Knowing the event is coming lets people prepare within the systems they already have, storing food, planning for drought, positioning aid. But it does not let them rebuild the deep machinery of farming and infrastructure in time. The warning buys preparation, not transformation. It helps a society brace for the blow rather than escape it entirely. Picture a driver on a highway who spots a hazard far ahead. If the car is nimble and the driver alert, there is time to slow, steer and avoid it. But now imagine the car is an enormous heavily loaded truck that takes a long distance to slow and a wide space to turn. The driver sees the hazard just as clearly, yet the vehicle simply cannot respond fast enough to avoid it entirely. The best the driver can do is brake hard and brace for a lighter impact. Human society is that heavy truck, and a super El Niño is the hazard that arrives faster than we can steer around it. The speed problem turns a difficult event into a genuinely dangerous one. A shock the world could adapt to over many years becomes a shock the world must simply endure, because it lands in a single season. And it lands on systems already stretched thin by the warmest baseline on record, systems with little slack and little time, facing a threat that moves faster than they possibly can. All of these threads now draw together into the single outcome that gives this whole story its weight. The stacked shocks, the vanished margin, the punishing speed, and the warm world they strike combine into one danger that the planet is genuinely unprepared to meet. It is the outcome hiding at the end of the road this El Niño is travelling, and it is time to name it plainly. Here is the outcome that ties this entire story together, the one the world is truly unprepared to face. a global food shock striking many regions at once, landing on a planet that has already spent the margin that once protected it, and moving too fast for the slow machinery of human society to adapt in time. That is the danger at the end of this El Niño's road, and it is the reason a warming patch of distant ocean deserves your full attention. Break it into its pieces and the shape becomes clear. A strong or very strong El Niño reaches into the world's major growing regions all at once. The monsoon lands, the African grain fields, the Asian rice paddies, the South American bread baskets, and pressures them together. The seas that supply a large share of the world's fish falter at the same moment, and all of it unfolds on the warmest baseline in the age of measurement, where every shortfall bites harder because so little cushion remains. The reason this outcome catches the world unprepared is the very connectedness that normally protects us. In an ordinary crisis, a struggling region leans on the healthy ones, buying food and drawing supplies from places the disaster did not reach. A super El Niño reaches nearly everywhere at once, so the healthy places are fewer, the supplies tighter, and the whole system strains together rather than sharing the load. The safety net works by spreading risk, and this event lands on every part of the net at the same time. History has already shown the worst version of this outcome in the famines that followed the giant of the 1870s, when a warm Pacific helped starve tens of millions who never knew what struck them. The world is far more resilient now, with forecasts and trade and reserves that century lacked. Yet the fundamental danger has not vanished. It has changed shape. The threat today is a strained and stressed global food supply, with rising prices and real hardship falling hardest on the places least able to bear them. Picture a single large family that has always kept a well-stocked pantry, able to weather any lean month by drawing on its stores. Over the years, the pantry has quietly emptied, the reserves spent bit by bit until only a thin supply remains. Then comes a season when the garden, the market, and the neighbours all fall short at once. In the past, the full pantry would have carried the family through. Now, with the shelves nearly bare, the same lean season becomes a genuine crisis. The world's food system is that pantry, and a super El Niño is the season when everything falls short together. This is the outcome nobody is ready for. Not because it is unimaginable, but because the world has grown so accustomed to abundance that it has forgotten how thin the margins have become. A super El Niño striking a warm and stretched planet threatens to reveal that thinness all at once, in a single stressed and difficult year that arrives faster than we can fully prepare for. Yet the story does not end in despair, and it should not. Because unlike the people of the 1870s, we can see this coming. We have months of warning, a clear view of the ocean, and real tools to soften the blow. The final question is what that warning is worth, and how the one advantage we hold, the power to see the future arriving, can turn a catastrophe into something we survive. The single most important difference between this El Niño and the monsters of the past is that we can see it coming, and that changes everything about how the story ends. The people who suffered through the great famines of earlier centuries met their disaster blind, with no forecast, no advisory, no name for the force that turned against them. We meet ours with months of warning, a clear view of the warming ocean, and the tools to prepare. That warning is the one advantage that history never had. Consider what the warning makes possible. Knowing a strong El Niño is likely lets farmers choose hardier crops, plant on different schedules, and brace for drought or flood before it arrives. It lets governments build up food reserves, position aid where it will be needed, and warn the regions most at risk. It lets aid groups pre-stage supplies for the floods and droughts the forecasts point toward. None of this stops the El Niño, but all of it softens the blow, turning some of what would have been catastrophe into hardship the world can manage. The warning works best when it's acted upon early, during the quiet months before the worst arrives. Remember the delay built into this event, the way the ocean loads its heat now and the world feels the full weight later. That delay, so dangerous when ignored, becomes a gift when used. It is a window of months in which to prepare, a head start that the blind centuries never had. The same lag that hides the danger also hands us the time to get ready for it. There is real power in simply understanding what is happening. When people know that a distant warm ocean is behind the failed rains and the rising prices, they can respond wisely instead of being blindsided. The famines of the past were made worse by ignorance, by the fact that no one understood the cause, and so no one could prepare. Knowledge breaks that helplessness. To see the ocean turn and to understand what its turning means is the first and most important defense. Picture a coastal town that has learned to read the signs of an approaching storm. In the distant past, such a storm arrived without warning and swept away everyone caught unaware. Today, the same town sees the storm forming on its instruments days ahead, sounds the alarm, moves people to safety, and secures what it can. The storm still comes, and it still does damage, but the town survives because it saw the danger and acted. We are that town now, watching this El Niño form on our instruments, with time to prepare that our ancestors could only have dreamed of. So the outcome nobody is ready for is not a fate written in stone. It is a warning, and a warning is something we can answer. The ocean has flipped its great switch. The warm water is sliding east, and the months ahead will test the world's harvests and its resilience. But we can see it. We understand it. And for the first time in the long history of these giants, we have the chance to meet one with our eyes open rather than closed. That is why a warming patch of distant sea deserves an hour of your attention. Not because the future it points to is certain, but because it is still ours to shape. The switch has turned. The warning has sounded. What we do with the time it buys us is the one part of this story that has not yet been written. Watch the ocean, understand what it is telling you, and prepare.